Okay, so hi guys, here's the video for C-7, and in this video we're going to learn how to use something called the power rule for derivatives, which I have written here, but we're going to talk first about where that comes from. Okay, don't even worry, you don't even have to look at it yet. Okay, so right now, if I have a function x squared, and I want a formula that will give me the derivative of x squared at any value, okay, so the slope of the tangent line at any point, if I want a formula that will give me that, I have this limit process that I could use, and for x squared, when I do this limit process and I do the side work, I end up with 2x being the derivative of x squared. And then similarly, if I do that same limit process for x to the third, I end up with 3x squared would be the derivative of that. And by the derivative, we mean the slope of the tangent line. And so it is this formula. Like if I want the slope of the slope of the tangent line to this graph at x equals 1, then I would just plug 1 in here and I would get 3. Okay, so the slope of the tangent line to this graph at 1 would be 3. Okay, so example. But guys, if you just keep doing this limit process over and over again, like for x squared, for x to the third, for x to the fourth, you're gonna see a pattern. Here guys, let me turn the light on. You're going to start to see a pattern, and that pattern is going to give you a formula. And then you could use that formula in the future instead of doing the limit process. Okay, so we just saw, so here we have f of x, here we have f prime of x, which is the derivative. So for x squared, it's 2x. For x to the third, it's 3x squared. Now x to the fourth, I didn't show you the limit process, but if you do it, you'll get this. Kind of a long process. There's a lot of side work. And then if you do it for x to the fifth, it's some kind of heavy algebra there, you get this, all right? Now guys, there's a pattern here. What happens, notice what happens with the exponent on the original function. The exponent turns into the coefficient. And then what's the new exponent? Okay, so this new exponent is 1. The old one was 2, the new one is 1. So the exponents are going down 1, and what was the exponent before becomes the coefficient in front. So like if I want the derivative of x to the n, where n just stands for any number, I would take this exponent n, I'd bring it down, there's our x, and then instead of an n, we would just have an n minus 1. Instead of a 5, you have a 4. Instead of a 4, you have a 3, okay, etc. So this is basically the power rule formula, but it also works like if you have a constant, let's call it a. If I have a constant a coefficient already in front of the x, well, the a stays there like that. So this is the power rule formula, like in its form that we're going to be using. All right, so here it is. So the power rule for derivatives. If you have a function of the form a times x to the n, then the derivative is a times n x to the n minus 1. This power rule only works if you have a function of the form ax to the n, all right? And guys, just as far as notation goes, let me just say a couple things. Okay, so very often instead of f of x, you're going to have y, and then you can express the derivative as dy dx. Okay, that'd be like the change in y over the change in x. But sometimes you'll have y, and this is just like a lot to write, sometimes dy dx, so sometimes they'll just say y prime. All right, so these are all ways of using notation for the derivative. All right, so here we go. Now, sometimes when you use the power rule, it's going to be super straightforward, all right? And when I say straightforward, I mean that the function is already of the form ax to the n, all right? In this, sometimes, a lot of times the a will be 1, all right? But this is of the form ax to the n. So a is 1, x, n is 10. So the power rule goes 10 times x to the 10 minus 1. So dy dx is 10x to the 9. All right, this one is also of the form ax to the n. A is 1, x, and then n is 3 over 8. So this is, you bring down the exponent times x to the 3 over 8 minus 1. So that's really minus 8 over 8. So we get 3/8 x to the negative 5/8. Right? Here's this next one. It's of the form ax to the n. A is 1, n is negative 2. So I bring down negative 2 times x to the negative 2 minus 1. Negative 2x to the negative 3. Here again, ax to the n. So this time my a is not 1, my a is 3. So I just write down 3. And then I'm multiplying it by, what am I doing? It's 1 over 2. X to the negative 1 over 2 minus 1, which is 2 over 2. So this is negative 3/2 x to the negative 3/2. Okay, one more. Also of the form ax to the n. So I just bring over the a times n x to the n minus 1. So this is negative 16/7 x to the negative 5. All right, so that's when you have a straightforward power rule situation. All of the form ax to the n, all right? Your original function is already in that form. But sometimes, guys, it's not going to be in that form right off the bat. So here, these examples, you've got to convert first in order to use the power rule. All right, so down here, okay, so these are not of the form ax to the n yet. Sometimes you can't convert into the form ax to the n. So then we couldn't use the power rule. But if you can convert to ax to the n, then you can use the power rule. Okay, so we're going to do some conversions first. So the 7th root of x to the 3rd. So I can convert this. This is x to the 3/7. Right? So I convert first, then I can use, so now it's of the form ax to the n, now I can use the power rule. 3/7 times x is 3/7 minus 7/7. And go ahead of me, guys, if you've got this. So this is 3/7 x to the negative 4/7. Okay. And then this one, okay, so this is x to the negative 23rd. And then this is negative 23x to the negative 23. And guys, your practice is on delta math, and you don't have to show, like the way I'm showing the subtraction, you know, if you don't feel like you need to do that, then you don't have to. All right, now this one. This is 1 over x to the 1/5, but it's not yet in the form ax to the n, so this is x to the negative 1/5. Negative 1/5 x to the negative 1/5 minus 5/5. Negative 6/5. Okay, we'll keep going. This is 11 over x to the 7 halves. 11x to the negative 7 halves. 11 times negative 7. All right, so this is negative 77 halves x to the negative 9 halves. Okay. Now guys, this one is just 5. So it's like, so this is like just A. But I can make this 5x to the 0. Because anything to the 0 power is just 1. So this is like 5 times 1, so 5 times x to the 0. So this is 5 times 0, x to the 0 minus 1. Now guys, here's the thing. We've got 3 things being multiplied here. And as long as you've got a factor of 0 somewhere involved, that makes the entire thing 0. 5 times 0 is 0. 0 times anything is 0. That's just 0. Now this is kind of tricky. Be careful here. E to the third is just a number. So this is another situation just like the one above it. E to the third, let me just show you. E to the third, that's a number, guys. It's about 20. So this is, again, just of the form A. But we want this to be of the form ax to the n. So this is e to the third times x to the 0 again. So e to the third times 0 times x to the 0 minus 1. This is, again, just 0. Okay, and then finally, this is 2 over 5x to the 3/4, 2/5 x to the negative 3/4. Negative 3/4 minus 4/4. All right, what does this end up being? This ends up being negative 3/10 x to the negative 7/4. All righty, now, so there was a bunch of examples, guys. Now, in Delta Math, they're going to want you to convert, they're going to want your answers, unless the directions say so, guys, these are fine answers. These are fine answers. But in Delta Math, they're going to ask you to have no negative exponents and to put back in radical form. So, so let's just go to this last example real quick. So if I wanted to put this back in radical form, this would be, well, first I'd have to get rid of the negative exponent. So this would be 1 over x to the positive 7/4. And then this is negative 3/10, 1 over. Now, if you've got a fractional exponent, it's the bottom number that is the index of the radical. All right, so it's that bottom number that goes right outside the radical here, and then it's the top number that is the exponent, right? And so Delta Math is going to want this example to be like negative 3 over 10 4th root of x to the 7th. All right. And then I'll just say for Delta Math, they're going to want you to convert back. But I am not, if I write the problems, I'm not going to say to convert back. but delta math happens too. Alrighty guys, I know it was kind of a long video, but I hope it was straightforward. I just wanted to show you a bunch of examples so that when you're doing delta math, you know how to handle what comes up. Alrighty, you shoot me a text if you have any questions or an email. You know, I've got the Remind app. If you're not signed up for that, make sure that you do sign up. I'll talk to you later. Bye-bye.